So I'm here to talk about Spacemesh, the project I'm working on, but there's a bigger context, and that context is decentralization, okay? It's kind of the reason we're all here. It's what brought me into this industry 7 years ago, and it's a word we tend to throw around and use quite a bit without always being really thoughtful what we mean when we talk about decentralization. So I'm going to begin by talking about this concept, what decentralization is, how we should think about it, why it matters so much, and then I'll transition and talk a little bit about decentralization in the context of my project, Spacemesh. I have been around since 2017, again, 7 years, hard to believe. Was fortunate to have the opportunity to join the Ethereum Foundation in 2017 and work as an Ethereum core developer for a couple of years. What initially brought me, so I have a background in traditional finance, and what attracted me to Ethereum and to this space was the promise of building decentralized systems. And I think of these as kind of, censorship resistant, credibly neutral value creation networks that are permissionless, that ordinary people, right? Not privileged elites, not accredited investors, but ordinary people all over the world can join permissionlessly, and they can begin to create value for themselves, for their families, for their communities. That's what attracted me to Ethereum 7 years ago, and that's why I'm still here. And that's what we're working on at Spacemesh. This is a talk I gave. This is the very first Ethereum talk I gave in Taiwan 7 years ago. But yeah, exciting to be here in Korea as well. So let me talk a little bit about Spacemesh just so people have background. Spacemesh is a layer 1 protocol. We began working on it in 2018. After 5 years of very intensive R&D, we finally launched the network in July of last year, which is a huge milestone. So I'm very excited now to be able to talk about Spacemesh, not only in theory, but in practice. It is completely dedicated to two things. Okay, the first goal of Spacemesh is to make mining from home easier than it's ever been before. And the vision is very simple. Any ordinary person who has an ordinary desktop computer with an ordinary internet connection anywhere in the world can download the Spacemesh software, right? It's just a single app, and it takes about 5 minutes to onboard, and that's it. It's really that simple. You download it, you onboard, you minimize it, the app runs in the background, and you begin earning coins. And this is so significant because there are, I believe, hundreds of millions, if not billions of people around the world who don't necessarily have access to specialized mining hardware, who don't have the expertise to run nodes in the cloud, who don't necessarily have access to things like credit cards and bank accounts and cryptocurrency exchanges. And so the vision for Spacemesh is to be the easiest way for anyone anywhere in the world to onboard and earn their first coins. I said we're dedicated to two things. The second thing is building the most decentralized blockchain in history. Our goal is to have 1 million mining nodes on the network. We're well on our way towards that goal. I'll show some numbers in a few minutes. But actually, these two goals are one and the same, because the only way you can have 1 million nodes is if you have ordinary people running your software on ordinary computers. So brief outline, I'll talk again a bit about background, what is decentralization, how should we think about it, how should we define it, how do we measure it. I'll talk about decentralization in the context of the Spacemesh project and how we're doing. The main thing I want to talk about is, as the title of this talk suggests, why decentralization is so hard, right? And why we're one of the very few projects that really are just maximally focused on decentralization, and what we're doing to address the challenges we're facing. And then I'll conclude by looking to the future a little bit for Spacemesh. So what is decentralization? The best resource I found on this topic was this great article by our friend Vitalik, also 7 years ago. 2017 was a big year. So for those who haven't seen this, I really encourage you to read it. I think it's on, Medium. And for those who have read it, like I did as I was preparing this talk, like go back, reread it again. Vitalik talks about 3 types of decentralization in this article, also talks about 3 reasons it matters. I'm going to walk through that, his ideas here, and just add some commentary and add a couple of thoughts. So the first 3, logical, architectural, political, these are the types of decentralization that the article talks about. Very, very, very briefly, logical decentralization talks about whether a system functions as a single monolith or whether you can kind of cut it into many pieces and it's more of like an amorphous swarm. So a blockchain is actually logically centralized, right? Because we want a single central source of truth, a single central state machine. Something like BitTorrent is logically decentralized, right? You could split the BitTorrent network in half and both halves would continue to function fine. But just to reemphasize, right, blockchain is centralized in this way. And this is why it's so important to understand that there's these different dimensions of decentralization. Architectural decentralization is the thing that most of us mean when we talk about decentralization in the blockchain space. A very simplistic, reductionist way to think about it is like how many nodes are in your network. I'll talk more in a moment about why we need to think about this in other terms as well. I won't go so much into political and economic decentralization in this talk. I'll touch upon it very briefly. But it's important, again, to point out you may have many, many, many hundreds of thousands, millions of nodes on your network. But if they're all run by the same actors, or in the case of proof of stake, and again, I added economic to this list because I think in an era of proof of stake, it really is important to understand how many actors collectively can do things like halt your proof of stake chain, which is what the Nakamoto coefficient measures. Right? If you have many nodes, but a tiny number of stakers or a tiny number of actors behind them, then it's not a terribly meaningfully decentralized network. So then the article goes on to talk about why decentralization matters. I think this is really important too. Fault tolerance is pretty straightforward. It's not terribly controversial. It's a topic that's been around since way before blockchain, and you see this very often in things like in mission critical systems like airplanes, right? The way that the hardware and the computing infrastructure on an airplane works is decentralized for this reason. Electrical grids, things like this, are also decentralized for this reason. And in particular, the goal here is to avoid something called common mode failure. The idea of common mode failure is that, again, you may have many, many nodes in your network, but if they're all running the same software, right, the same version of the software, if they were all downloaded using the same supply chain, if they're all running on the same operating system, or, if they're in the same geography, or maybe they're in many geographies, but they're all hosted on, let's say, AWS data centers, you see what I'm getting at here, right? There's many, many kind of vectors here, and a failure in any one of those things, right? You may have a bug in a single release of your software, and if everyone's running that software, it doesn't matter how many nodes you have, right? The whole network is going to crash. So in order to avoid common mode failure, we really need to think in a quite sophisticated way about decentralization and about maximizing decentralization along all those vectors. Attack resistance is like fault tolerance, where the types of faults you're defending against are kind of intentional faults. And I'll just, again, use the example of the software supply chain. It's possible not that there's a bug, but that there's some sort of malicious exploit that gets injected into your software. This happens fairly often. And again, the more architectural decentralization we have, the safer we are against that type of attack. Collusion resistance, it's a very nuanced, very important topic. I'm not going to go into it in this talk, but I encourage you to read about it in the article. So with that background in place, let's briefly look at some numbers in the context of the live Spacemesh network. We have this thing called the network dashboard. So if you go to dash.spacemesh.io in your web browser, or you just search for Spacemesh dashboard, you'll see this. There's a lot of nice shaped graphs here up and to the right. The latest number from Epoch 17, which I think these slides are a couple of days old, I think it's still the latest, is about 1.5 million smeshers on the network. Smesher is what we call a miner. I'll explain what that means in a moment. And the network security, it says 1.2 exabytes. I'll talk about that more in a second as well. This is, again, that number of smeshers or miners, rapidly approaching 2 million. As a builder, as an entrepreneur, there's no feeling more exciting or more rewarding than being able to stand on a stage like this in front of an audience and point to a hockey stick graph like this that's just up and to the right. So it's really exciting. The Spacemesh network has seen extraordinary growth since we launched 8 or 9 months ago. Just a couple points to make here. The first is these miners, these are miner identities in the network, and they don't map one-to-one to individuals or to companies or something like that. It's very often the case that one person, one miner, is running 10, or in extreme cases, even 100 or 1,000 miner identities. Like, for example, I ran a few. So we don't know the exact number of miners in the network, but it's a very large number, and it's growing very rapidly, and that's very, very exciting. The other point to make here is that this is around 2 orders of magnitude more than we designed Spacemesh to handle. And I'll come back in a moment to why that's a problem, but it's one of the main reasons decentralization is so hard. This is security. So the Spacemesh network uses hard drive space for mining rather than, it's not based on proof of work or proof of stake. We have a bespoke consensus mechanism called proof of space-time. And so we measure security in terms of the number of bytes committed to the network. So this is 1.5 exabytes, again, rapidly approaching 2 exabytes. It's a very, very, very large number. It's kind of hard to contextualize or get your head around. But just to put things in perspective, this is something like 400 million high-quality MP3s, which is around 3 or 4 times the size of the entire Spotify catalog. This is 15 times the total storage in the Internet Archive Foundation, which is around 100 petabytes. Again, just an extraordinarily large amount of data. And it's so the last figure I saw for Filecoin, which is another awesome project that's obviously been alive for a few years, is that it's storing around 2 exabytes worth of data. So we're rapidly catching up with that number, which again is just extraordinary, having been live for only a few months. This is actually an even more interesting statistic in the sense that, so this is the number of unique nodes or peers on the Spacemesh network that our infrastructure has seen. And the reason I like this is that it's a real world phenomenon, right? This is not some kind of in-protocol thing like miner identities. This is like actual systems on the internet with a unique IP address. And yeah, you can see we're on the order of 20,000. The number's gone up and down, and this is like an aggregate data set, so don't read too much into the peaks and troughs. The last time I checked, Ethereum was on the order of 8 to 10,000, and Bitcoin is on the order of 20,000. So similar to Spacemesh. We have a long way to go. I said our goal is to get to 1 million, but yeah, I think it's really exciting to see that we have a similar number of nodes to Bitcoin for a network that hasn't been alive for very long. So going back to that dashboard for a second, we have this thing down here that you may or may not have noticed called the decentralization ratio, right? What is this? It says 82 out of 100. This is a pretty arbitrary, pretty subjective equation that we came up with. It was a first attempt. We came up with this a couple of years ago before we launched the network, and it's really a weighted average of 2 figures. The first is the number of miners divided by 10,000, which we designed Spacemesh for. We arbitrarily decided if we have 10,000 miners in the network, we'll be really excited. And then the other thing is the Gini coefficient, which measures the weights of the miners who have contributed blocks over the past 100 epochs. And the weight here is proportional to the amount of size that the number of bytes that the miners have committed to the network. The main reason I put this up here is to show that we were really off when we came up with this statistic, that, that 82, whatever, we're probably more at 3 or 4% of where we need to be with respect to decentralization. And so it's really, really hard, right? It's a very hard thing to do to reduce all of those dimensions of decentralization that I showed earlier to a single number. But I still do think it's worth trying. And if you're interested in this, if you have ideas about how to do better, please come talk to me, because I think KPIs are important, right? We need things to work towards. Cool. So yeah, let's talk about the main thing, which is why decentralization is so hard and what we're doing to address some of the challenges we're facing. I hinted at some of these things before. The first, and I think the most important thing about Spacemesh is, as I've said a few times, our focus is on home miners, right? We want to make it easy for people who are not super sophisticated, don't have a ton of DevOps expertise, to run the Spacemesh software and be able to mine from home. And to the best of my knowledge, we're the only layer 1 that's focusing on this. And if you look at networks like Ethereum and Solana and many others, the vast majority of nodes are running on things like Linux VMs in the cloud, right? Which is where you should be running node infrastructure. But running nodes at home is hard for a bunch of reasons. We've tried to make it easy. We have an app you can just download. But the reality is you need your desktop computer to be on 24/7. There's pretty high resource requirements, which I'll talk about in a sec. There's frequent updates. You have to kind of keep updating your software every few days. And so there's no easy mitigation here, but what we're working on to improve this is basically taking more of a product mindset, right? We're a bunch of systems engineers and back-end hackers, and we only very recently added a product person to our team, but we really plan to improve the usability of mining from home, running Spacemesh software at home. The second is peer-to-peer. All blockchain networks are effectively peer-to-peer networks, but again, they're mostly running on things like cloud VMs or dedicated hardware, dedicated internet connections. And it turns out, I know significantly more about the nitty-gritty details of peer-to-peer and TCP/IP and how ISPs work than I ever wanted or intended to. because we've really been in the guts of networking, the networking stack. It's very, very difficult to run high bandwidth, intensive peer-to-peer applications on a real home internet connection. The internet is just not designed to support this use case. Peer-to-peer is really, really hard. A lot of ISPs make it difficult. They do things like masking IP addresses. People are running nodes behind home routers and firewalls and things like this. So this has been a big challenge for us. It is too hard right now to keep a node in sync when you're running on a home internet connection. The good news is we are standing on the shoulders of giants. We're building on very robust infrastructure, libp2p for folks who are familiar with it. Filecoin, IPFS use it. Ethereum's using it as well. And we kind of know what needs to happen. We need to do things like hole punching, and we have amazing network engineers working on it. So this part at least will get easier soon. The next is resources. I hinted at this before. The way the Spacemesh protocol was designed, the complexity goes up linearly in the number of miners. That was just a naive design decision. We didn't factor in that we would see such explosive growth and have millions of miners joining the network. We expected, as I said, something on the order of thousands. And unfortunately, that means that every one of those miners needs to generate a proof and gossip it to the network. And at the moment, every node on the network needs to download all of those millions of proofs and validate them every epoch, which takes a very long time and consumes a lot of resources, both bandwidth as well as compute resources and memory to some extent on home computers. This is a challenge, and we need to make some core protocol upgrades to address this. The good news here is that we know what needs to happen. We have two projects in particular that we're working on right now. The first is distributed verification. So it will no longer be the case that every node needs to validate every proof, basically. And the second is allowing miners who are operating many of those miner identities to merge them together. So we expect to see a reduction of at least 10x, if not greater, in the number of miner identities once we roll out this merge feature. So these are protocol upgrades. They'll take time, but the resource requirements will come down. The next topic is pools. So quick quiz question. Does anyone know when the first Bitcoin mining pool launched? Anyone want to guess what year it was? 11. Okay, pretty close. So the answer is 2010, actually. And I learned that putting this presentation together. I was really surprised, but it goes to show that, and that was it's called Brains today, but it's cool that that network's been around since then. It goes to show that pools have been with us since the very earliest days, the very beginning. And it's almost a thing to celebrate that we have active pools in Spacemesh, because it's kind of like a hallmark of being a successful project, I would say. Pools are kind of a mixed blessing. On the one hand, they're like a sophisticated point of contact for us as network operators. It's very difficult, as you can imagine, to coordinate with tens of thousands, hundreds of thousands of home miners when we need to do things like addressing bugs and rolling out updates. So having kind of these technical points of contact who operate a large part of the infrastructure in the network is actually helpful in some ways. Of course, from a decentralization perspective, pools are not optimal. Pools can be operated in a more or less decentralized way. Long story short, pools are a very, very controversial topic in Spacemesh. We are a totally permissionless protocol, like Ethereum, like Bitcoin, and so we couldn't sort of put our foot down and ban pools even if we wanted to. So we kind of have like a multi-prong approach to thinking about pools and addressing them. The first is having many competing pools is better than having a single pool. So we want to make it easier to have, we want to make the protocol pool friendly in some ways, and have like open source pooling software to encourage competition. We need to continue to remove incentives for users to join pools. So the key thing about Spacemesh, in addition to it being, as I said, targeting home miners, is the fact that even the smallest mining node in the network, the minimum commitment size is 256 gigabytes, right? Even the smallest node is guaranteed one reward slot every epoch, every 2 weeks, without joining a pool, right? So there's no hard economic incentive for those small home miners to join pools. That was a key part of our value proposition. However, because it's hard to run a node from home, as I said a moment ago, users do end up joining pools anyway. So we need to remove those incentives for joining pools. And we need to continue to educate users about the risks and the trade-offs of joining pools, how it hurts decentralization and in many cases involves things like giving up your private keys, which are never safe to do. And finally, economics. This is a screenshot from a mining pool that does include Spacemesh. And as you can see from the circled number there, per unit space, so in this case, per petabyte, and this is by now, I don't know, a few days out of date, so it's probably come down a little bit. But it is significantly more profitable at this moment to mine Spacemesh than it is to mine, for example, Chia, which you can see 2 or 3 slots above, right? More than an order of magnitude more profitable. At the moment, a small home miner, so I said a moment ago, like 256 gigabytes is the minimum, right? A miner who has that amount of space in the network is earning a few dollars per epoch, a few dollars per month, something on the order of like $4 or $5 US per month. We expect that will fall probably another order of magnitude. That's just economics. There's nothing we can do about it, but it will be very interesting to see over time how the kind of long tail of home miners, like whether that changes as the economics of the network change and as the network finds like an economic equilibrium. So in the final few minutes here, just briefly touch upon things we're doing to improve and become more decentralized. So I mentioned all of these before, but just to reiterate, improving the product experience, UX is very, very important. Improving the peer-to-peer network, making sure it's very easy to run a node from home, right? This is key to decentralization. Rolling out those major protocol upgrades I talked about, right? It's clear what we need to do. It will take some time. Continuing to reduce the incentives to join pools. In parallel to that, we want to educate users about the risks and trade-offs of pools and also make it easier to run competing pools. All of these things will get us closer to our goal of 1 million nodes and being the most decentralized blockchain network. The final thing I want to touch upon is the VM, the virtual machine. This topic came up a few times today, most notably in Adrian's talk about intent machines. I put this up here to show these are all things that we've researched and thought about in the process of designing the Spacemesh virtual machine. So we launched Spacemesh. We made the difficult decision to launch Spacemesh last year without a full VM. Okay, at this moment, we have a very small set of hard-coded smart contracts, you could call it. They're called precompiles. But we haven't launched the full-featured VM yet. I am myself a VM engineer. This is what I was working on at Ethereum back in the day, and it's the piece of Spacemesh I've been the most excited about. We designed and built a WebAssembly-based VM called SVM, the Spacemesh Virtual Machine, and we tabled the entire thing a couple of years ago. Also a very difficult decision because the goalposts had moved so much. There's just an enormous number of things to consider here, right? Is it a layer 1 strategy? Is it a layer 2 strategy? Where does the data go? What type of rollup do you want? What type of sovereignty do you have? What architecture are you using? Are you using an existing blockchain-specific VM like Move or EVM or the Solana VM, or something that's more global standard like RISC-V or WebAssembly, et cetera, all these different models, account models. I'm really excited to announce that we released just 2 or 3 days ago our preliminary design, our high-level design for the Spacemesh VM. It's called Athena. We have not yet released the kind of full document. That's going to come out, well, as soon as I have a few minutes to kind of finish working on it with my team. But I'll show you in a moment my Substack link. There's an article there introducing it. We are doing a very unique, very creative, novel roll-up design that is an optimistic roll-up that's built using RISC-V, which will allow developers to write smart contracts in Rust and their other favorite programming languages. There's some really, really exciting, unique things in there where there's a zero-knowledge component as well. We think it represents the best practice of kind of blockchain VM design today, and you'll be hearing a lot more about it very soon. So that's basically it. I'll just leave with a few resources. So I mentioned Substack a moment ago. I write very actively about Spacemesh there. I wrote about Athena there, so take a look at that if the VM stuff is interesting. Active on Twitter and Farcaster. Spacemesh.io is our website, and I'm sorry I don't have a QR code, but if you go to chat.spacemesh.io, you can access our Discord there. And I will just leave everyone here with a quote from Jaron Lanier. He is a brilliant thinker. He's one of my personal heroes, and he's written more eloquently and spoken more eloquently about the challenges that we face in these value creation networks today with centralized operators, things like social media as it exists today. And our goal is to solve this problem and, again, remove the centralized actor and just build these decentralized value creation networks that all of us and ordinary people everywhere can join and participate and create value for themselves, for their families, for their communities. Thank you.